Minecraft Championship, or MCC, is a monthly event where teams of 4 Minecraft content creators play a bunch of mini-games. The best one of these games is Sands of Time, a dungeon crawling challenge where each team works together to get the most gold they can from their own copy of the map. The dungeon is filled with traps, enemies, vaults, and for the purposes of this video, puzzles. This puzzle often shows up next to the main room, and it's the one we're going to solve today. The goal is to get the blue block to fall into the blue space, which will reward the player with gold. Note the pistons on the side of the puzzle. You can activate these to push the blocks around. None of the black dummy blocks are affected by gravity, so you won't have to worry about them falling into the blue space. If you get stuck, you're allowed to reset the puzzle once, but you don't get a third chance. This puzzle was first seen in MCC 15, and since then, there have been several different variations. Our objective is to figure out how to solve this puzzle no matter where the blocks start off, and this video will explain one reliable, easy-to-use strategy. If you're an MCC player and you want a more complete guide, there's a link in the description, as well as a link to a world download if you'd like to try the puzzle in-game. There's also an applet created by Reddit user CTL Advance, which can generate random puzzles for you to try. If you haven't seen Sands of Time before, you should know some basics before we talk about this puzzle. Your time in the dungeon is tracked by a sand timer in the starting room, and there's pieces of sand that you can use to refill the timer, which are scattered in the starting area and down various paths. The most common strategy for exploring the dungeon is to have 3 teammates go down paths and try to open vaults, while the 4th person stays in the main room keeping track of the timer. The only way to score points is to pick up gold throughout the dungeon, so this piston puzzle has a lucrative reward. But if you spend too much time solving this puzzle, that's time you're not spending collecting sand, which means all of your teammates have less time to explore the dungeon. Usually, MCC players will try to solve the puzzles after most of the paths have been explored, when they only have a little bit of time left. When this puzzle shows up, it's always next to the main room, so a team that stays organized will always have some time to think about it and get a nice bump to their score. But it'll only be some time, and in MCC, there's often a lot of pressure, because if you're still in the dungeon when the timer runs out, you lose all the gold you've collected. So ideally, we want a reliable, not too complicated strategy, perhaps something that you can do in the last 90 seconds while you're waiting for your teammates to come back to the main room. Let's take a look at this puzzle, which players attempted to solve in MCC 16. A good first step to solving an unfamiliar puzzle is to play around with it. So I encourage you to look at that browser game or check out the world download. Pen and paper couldn't hurt either. As you try things out, keep track of what you notice. Huh, looks like a lot of these piston heads are in our way. Let's clean those up. Actually, let's make it a habit that we retract the pistons like this, because it doesn't ever help us to have them in our way. Hmm. The pistons can't pull any blocks, so if we want to put a block in this top right corner, we'd have to push a block from right next to it to get it there. But the pistons can only reach so far. If we want to actually push any blocks, we need to have all the blocks in between as well. So this block in the 3rd row could help us, but we also need a block in that bottom right corner. Huh. And if we want to get a block to move to this top right corner, we need to have a block in this top left corner as well. Wait a second. There aren't any blocks in the corners anymore. So does that mean... Yeah, I don't think we can get any blocks to corners anymore. Let's figure out what we did. Aha! We moved a block away from the bottom right corner. So if we want to put a block back in that bottom right corner, we can't just undo that move. Right now, it looks like we'll need to use the bottom row. But once we do that, there won't be a block in the bottom left corner anymore. Hmm. And then, if we wanted to put a block in the bottom left, we'd have to move the block that's in the top corner. We may be onto something here. In order to move a block to a corner, it looks like we need to move some other block away from a different corner. So if we keep track of the number of blocks we have in corners, we'll never be able to increase that number. We saw before that if we're not careful, we could make this number go all the way down to 0. And once this number is at 0, it's stuck there. For this puzzle, that seems pretty important. To get a block to the corner, we need to already have a block in the corner. And so now maybe we can solve this one. We just need to be more careful about moving blocks away from corners. Let's try to get all the blocks we need to the right-hand side, and then use that block on the bottom right to finish the job. Nice! This property, where the number of corner blocks can only decrease, has a special name, a monovariant property. In other words, this number can only move in one direction. In this case, it can only decrease. That was important because we didn't want our number to decrease to 0, since that made the puzzle impossible to solve. Let's keep track of this number in another puzzle, and we should also keep an eye out for any other useful ideas. Huh, looks like we're pretty stuck. Well, at least we're not totally stuck. We can still move blocks around in that second row and in the third column. But look at that second column. Neither of the pistons even work, because the entire column is filled with blocks. Looks like there's no space for them to extend. And then in the second row, even if we move blocks there, it looks like we can't ever remove a block from that second spot. That's pretty unfortunate. Let's see what happened. There it is. Once we filled up that second column, we couldn't move much anymore. And that makes sense. None of the pistons can reach this middle column directly, so we'll need to have all the blocks in between in order to push something out of that column. But then, once we activate the piston, we just replace the block we pushed out with another one, so the column stays full. And if we think about it, that should work the same way even if the column isn't completely full. Look at that third column. It has 3 blocks in it now. In order to push a block out of this column, we'd need to replace it with another one. We might be able to add one if we could find a way to move a block from a different column into the empty slot. But it looks like this is a monovariant property as well. The number of blocks in one of these middle columns or rows can only increase. Maybe we're getting somewhere with this monovariant property idea. Anyway, it looks like if we fill up one of these rows or columns in the middle, we'll usually get stuck. So let's try to avoid that if we can. Okay, haven't gotten stuck so far. We're out of corner blocks again. Fortunately, we don't need to get to the corner this time, so we might be okay. Interesting. We've almost got a 3 by 3 square here. Let's look at the middle rows and columns. 3 blocks each. Hopefully we don't add a fourth block to any of them, because then we'll get stuck. Wait a second. Is it even possible to add a fourth block and get stuck? It looks like the empty slot is only ever on the top or bottom of this column. How could we move a block there? To do that, we'd need blocks here or here. Aha! That would require a block to be in the corner in order to push left or right. And since we've run out of corner blocks, we'll never get one back. And that means we'll never get stuck. So then, if all of the middle rows and columns will never have more than 3 blocks because we can't fill them up, and we said earlier that we can't ever decrease the number of blocks in a middle row or column, then each of the middle rows and columns will always have exactly 3 blocks from now on. It's possible this is a fancier way of getting stuck, but let's play around some more and see if we can make some progress. Ooh, here's a nice trick. We want to move the blue block to the top of this column. Well, right now it's stuck in the middle of the column. But watch this. If we move it out of the way like this, and then shift our column down, and then bring the block back, now it's on the top of that column. Success! Let's look at that trick more closely. If we want to move our blue block up a column, it looks like we could move it into an adjacent column, then shift our column down, then reinsert the block in a higher spot. Let's think about how that works. In order to actually move the blue block, it looks like we need to do a lot of shifting the same rows and columns back and forth. Whenever we have 3 blocks in a middle row and 3 blocks in a middle column, this should work, since there's enough space to shift in both directions as many times as we want. And there shouldn't be anything stopping us from doing the same thing with the rows, since this whole thing is symmetric. Let's highlight all the places we can move the blue block using just this strategy. We can get it anywhere in any of the middle rows or columns. So all of a sudden, we've found a strategy that covers nearly the whole board. In fact, we're only missing the corners. So with just these 8 blocks, we can get the blue block almost anywhere we want. Even better, we said earlier that if you get this setup, it's impossible to get stuck. We said that the number of blocks in each middle row and middle column will always be 3. It'll never vary. We call that an invariant property. You could think of the entire setup as one big invariant property, or you could look at the number of blocks in each row or column and call each of those invariant. Either way, this kind of setup went a long way towards solving our puzzle. Let's look at another puzzle. Now the goal's in the corner again. But the strategy we just discovered is so powerful, it can still be used to solve this puzzle too. Take a moment to think through how you'd solve this yourself. And remember, we're not looking for the optimal strategy. We just need something that'll work. First of all, our goal is in the corner, so we need to make sure we have a block in a corner. There's only one of those right now, so we should be very careful about moving that one. The key insight is what happens if we ignore that corner block for now and just look at what we have left. With a few moves, we can make that same 8-block setup as before, with 3 blocks in each row and column. So if we use the same tricks as before, we can get the blue block right next to the goal. Also notice that the corner block can't really get in our way, which is very handy. There we go. And now to push the block into the goal, we need a block in the top right corner. Well, we can do that. As long as we make sure that the 4th column is full first, we can push a block into that corner. Excellent. We may be onto something here. If we have a lot of blocks in our puzzle, all we need to do is use 8 of them to make this square with a corner missing, and leave any extra blocks in the corners. Then we can use those 8 blocks to move the blue block wherever we want. And if our goal happens to be in the corner, we can get the blue block next to the goal, and then use one of our leftover corner blocks to finish the job. This could be a solid strategy. If it's always easy to make that bunch of 8 or anything like it, then we're home free. So for the rest of this video, let's discuss some special cases, all centered on this strategy. First, we don't necessarily need an 8-block setup to take advantage of the same idea. Let's say we wanted to move the block up this column. In order to do that, we can use the same tricks as before. Shift the entire column up, then move to the side, then reinsert the blue block in a higher place in the column. Now look at this example. We won't be able to do the same thing, because once we get halfway up the column, we can't shift the blue block to the side anymore. What's the difference? In this upper row, there are only 2 blocks, so we'll reach a point where the pistons can't move anything side to side. It looks like we need 3 blocks to be able to do it. But maybe we could get a third block up to that row? Let's think about how we can do that. We'll need to fill in one of the empty spaces in this row, and right now, it looks like that'll have to be one of the side spots. In order to do that, we'll have to use one of the side columns. But in order to do that, we'll need enough blocks there, and that requires having a block in the corner again. There aren't any blocks in corners right now, and as we said earlier, that number can only decrease. That was the first monovariant property we noticed. Therefore, there's no way to get a third block to this row, so we have no way to push the blue block any higher. Let's highlight where the blue block can move when we have a 6 or 7 block setup instead of an 8 block setup. Notice that it's entirely based on where we have a row of 3 blocks intersecting a column of 3 blocks. This is all well and good, but we should also think about how to properly set up those 8 blocks. For example, how would we handle this puzzle? Well, we have 8 blocks, and the goal isn't in the corner, so all we need to do is set ourselves up properly. We need to avoid the one thing that went wrong, putting 4 blocks in a middle row or column. So for example, this would be a bad move, since we'll fill up the second row. To make this work, we'll need 3 blocks in the middle rows and 3 blocks in the middle columns. It looks like there aren't many blocks in that second row, but there are already 3 in the third row. So let's push all the blocks in the top row down, without pushing anything into the third row. Excellent. All of a sudden, we're almost there. Just move that other corner block to the right, and we're all set. This turns out to be the harder part of the solution, because once we get to this spot, the rest of the puzzle is extremely easy, and there's no way to mess up. But even for this first part, there's not much to it, and with a little bit of practice, it'll get easier to see what to do. Just don't fill a middle row or column, and you'll be okay. Or that's the hope. If the puzzle happens to start with a full row or column, then there's nothing we can do. That's a fairly easy thing to check, and if we have a solvable puzzle, then starting off with a full row or column can actually make the puzzle much easier in some ways. If you're interested in that, take a look at the guide in the description. Unfortunately, there is one other bad example that's going to give us a tough time. Let's look at this puzzle first. We don't have any full rows or columns, so we're in good shape. Counting up the blocks, we have 8, so we can use our invariant strategy again. Notice that our second row already has 3 blocks, so we don't want to fill it up. Fortunately, we can prevent that from happening very easily. Just activate one of the pistons in the second row, and it collapses the blocks together. Now we can only fill this row from one of the sides, and as we said earlier, we need to use a corner block in order to do that. Since corner blocks can always be pushed in one of 2 directions without any other blocks to help, we usually have a lot of flexibility with them. And so if there are 3 blocks in a row or column with a gap in the middle, and we want to use our invariant strategy, it's best to collapse that row or column right away. But now let's look at this example. It's almost identical to the previous one, but now if we collapse the second row, then the second column will fill up. Likewise, if we collapse the second column, the second row will fill up. If the puzzle starts in a position like this, then it could be extremely difficult, because you don't necessarily know where and when to fill up a row or column, but you'll never be able to use the foolproof invariant strategy. The solution to this puzzle requires no small amount of cleverness, and it's one of those rare puzzles where there are a lot of blocks, but no obvious path forward. None of the puzzles in MCC have ever been this difficult. But even this puzzle tells us something valuable. We know that it's difficult right away. We were never after perfection when it came to this puzzle. We wanted a consistent, pretty reliable strategy. If it were very easy to solve in all cases, it wouldn't be a proper puzzle, now would it? To quickly figure out what to do when I see a new puzzle, I usually do a few things. First, I count the number of blocks and see where the goal is. Then I see if there are any full rows or columns in the middle, or if we're forced to fill one up, like in this example. If you find a pattern of 6 blocks like this, then you're in trouble. But if you don't, then you can always avoid getting stuck. And if there are enough blocks, that means we can use our invariant strategy. If not being able to solve this puzzle easily feels like a letdown, I agree. Fortunately, many of the remaining cases, including this one, rely on some nice problem-solving principles. And if you're curious about all of those extra cases, there's a link in the description to that guide I mentioned. There's 2 reasons why I didn't present those, though. The first is that there's a lot of them, and in a high-pressure environment like Sands of Time, you're better off using a mostly quick, mostly mindless, mostly reliable strategy. The second is that this idea that uses monovariants and invariants is the kind of thing that's tough to figure out on the fly, but very easy to use once you know it. On the other hand, I've seen multiple people figure out some of the tricky puzzles in real time without having to use this strategy. So if anyone cared about practicing this puzzle, they'd probably figure out a lot without my help. This idea of using monovariant or invariant properties completely changed the game for us. Starting only from our instincts, we built an entire strategy around not getting stuck. I think it was crucial that we proved once we ran out of corner blocks, no amount of cleverness could give us one back. So we never needed to worry about missing some galaxy brain strategy. We just picked up a very important, easy to remember idea with no exceptions. 2 more things to mention before we go. First, math isn't a spectator event, and that applies to this puzzle too. Well, for most of us, MCC is a spectator event, but for you MCC players, who are definitely watching a math video until the end, it isn't. If you want to have this strategy in mind the next time you play Sands of Time, you should try it out a few times. Second, I have another puzzle for everyone to try that makes use of monovariant properties. Way back in the day, the legendary CubFan135 let us know how to fill an n by n pond with water. Just place all water sources on the diagonal of the pond, and then every block will become its own water source. This happens because of how water sources are created in Minecraft. If a block has at least 2 water sources that flow directly into it, then it will become a water source itself. So if you fill in the diagonal of an n by n pond, all of the blocks next to them become water sources, and then all the blocks next to those, and so on, until you reach the opposite corners. If you play around with this idea, you might be able to find another way of filling the pond starting with only n water sources. But my challenge to you is this. Can you fill in an entire pond starting with only n-1 water sources? And if not, can you prove why it's impossible? See if you can find a monovariant property to help you out here. That's all for now. See y'all next time!